Sea levels are increasing, Arctic ice is melting, Greenland is bursting with flowers, and glaciers are retreating. Stop the warming trend, or the planet will perish. This is essentially the constant message we've been exposed to over the course of many years. Why shouldn't we take it seriously when everyone keeps saying it? Few people still insist that the anthropogenic cause of global warming can only be inferred from intricate computer programs called general circulation models, which are still only unproven conjecture. Contrarily, the existence of natural climate variability that computer models are unable to replicate has been noted more and more in scientific literature. A sizable amount of the observed global warming since 1850 can be attributed to this natural variability. Therefore, the anthropogenic contribution to the observed climate change over the past century is unjustifiably overstated, and the dire predictions are unfounded. Climate is the most complex system on our planet, and as such, it necessitates proper and well-thought-out responses. A small group of climate change skeptics contend that climate simulation models fail to accurately simulate the observed natural climate variability, particularly when it comes to constructing the warm periods of the past 10,000 years. These periods, which include the well-known medieval warm period, the Roman warm period, and generally prolonged warm periods during the Holocene optimum, occurred around every 1,000 years. Despite having lower CO2 concentrations than now, these earlier times were much warmer than the present and are associated with millennia-long cycles of solar activity. So who should we pay attention to? Let's talk about it. First and foremost, those who believe that there is an impending climate catastrophe should limit their warnings to the potential existence of the human race, rather than the end of the world and all biological life. Our planet has experienced shifts of such scale during its roughly 4.5 billion year history that the current one, assuming it is real, resembles the bite of a minuscule fly. No, human activity cannot cause the Earth to become sick or die. Let's not deceive ourselves about this. Even if we like to think of ourselves as strong and unbeatable, the truth is that we are completely at the mercy of the natural world, where our existence means nothing. Let's think about the wonderful evolution of the dinosaurs, who lived for over 180 million years until being obliterated by the collision of an asteroid with a modest 10-kilometer diameter. The consequences of a typical explosion of a big star close to our Sun would be catastrophic. The Earth is neither sick nor dying. Rather, it is continuing its extraordinary adventurous existence, never exactly replicating itself and prepared to support life once more, as it has done on numerous occasions. In actuality, cycles of significant changes in the average global temperature have been observed in Earth's recent past. Glaciations, which appear to have occurred roughly every 100,000 years, are the most obvious evidence. Significant short-term fluctuations have lasted between glaciations and even during them, capable of completely changing the environment in which life might survive. In essence, glaciations impacted Europe up until roughly 10,000 years ago, at intervals of several thousand years within the larger 100,000-year cycle. Cycles, or repeating sets of occurrences, are the very foundation of our existence. In the universe and in our world, cycles come in huge variety. Some of these, such as the seasonal changes, yearly animal migrations, or the circadian rhythms that control our sleep patterns, are natural. Others, like crop planting and harvesting, musical beats, or business cycles, are man-made. What could have caused Earth's glaciations and thawing to alternate? Milankovitch, a Serbian mathematician, contributed to the discovery of the solution in the early 20th century. Through his studies, he became convinced that the Sun, Earth, and other planets are not ideal billiard balls traveling in continuous identical orbits and rotating in the same way, which might be used to characterize the entire cycle of major glaciations over the previous millions of years. In the universe, everything is always changing and becoming something new. More specifically, the Earth's orbit path has an eccentricity of about 0.0167 and is currently almost circular. That infers that there are about 5 million kilometers between aphelion and perihelion. Additionally, due to gravitational interactions with other planets, the eccentricity of the Earth's orbit can change up to a value of 0.058 during the course of a cycle of around 92,000 years, resulting in an aphelion and a perihelion distance variation that can reach 17 million kilometers. The tilt of the Earth's rotation axis to the plane of the ecliptic, which is currently 23.4 degrees and oscillates from 22.5 to 24.5 degrees in around 41,000 years, is another notable change. The third significant fluctuation is related to the axis orientation and is brought on by the equinox precession event. Due to this, the equinox line gradually shifts over time, circling 360 degrees in around 25,800 years. As a result, Earth adopts opposite inclinations with respect to the direction of fixed stars roughly every 12,900 years. But before moving on, don't forget to subscribe to our channel if you haven't already. Make sure you hit that notification bell so that you don't miss out on any of our videos. These astronomical cycles affect how much solar energy reaches Earth at certain latitudes and seasons. For instance, a more inclined axis results in more pronounced temperature changes across seasons, whereas a less inclined axis produces more consistent seasons. The total solar energy that Earth receives over the course of a year varies as a result of orbital eccentricity. These cycles' combined influence have the potential to significantly alter Earth's climate. Warmer periods, known as interglacial periods, can occur when variations synchronize so that solar energy is focused in the northern hemisphere during the summer months. Sea levels rise and glaciers retreat during these periods. On the other hand, glacial periods, which are marked by widespread ice cover and lower sea levels, can occur when fluctuations result in diminished solar energy in the northern areas. It is vital to realize that seemingly insignificant temperature differences control the transition between glacial and interglacial periods in this regard. Remember that a glacial period's average temperature is only 4 to 6 degrees Celsius lower than an interglacial period's average temperature. The impacts that can be seen, however, are striking. Life on Earth becomes fairly hostile during ice ages. Much of North America and Europe, as well as areas of Asia and South America, are covered by thick ice sheets similar to those that currently exist at the poles. Sea levels drastically decline when glaciers hold more and more water. For instance, it is estimated that the average sea level fell by around 120 meters during the last glacial epoch, converting the Baltic Sea into a lake and changing the United Kingdom into a peninsular home to mammoths and enormous hairy rhinoceroses. On the other hand, during interglacial times, like the current one, the climate gets noticeably milder. Sea levels increase as northern Europe largely emerges from the ice. Analysis of climate data and geological evidence has shown the relationship between Milankovitch's cycles and Earth's climate. Climate change over millennia, which can be correlated to astronomical cycles, is well documented in ice layers, marine sediments, and carbonate deposits in caves. Thus, Milankovitch's idea has developed into the strongest defense against the thesis that human activity is to blame for the Earth's warming over the previous 2 decades. It must be acknowledged that this theory of cycles by the Serbian mathematician has only been somewhat successful in explaining long-term climate changes, those caused by significant glaciations interspersed by periods of thousands of years. As a result, those who believe in man-made global warming and who promote this theory have little trouble refuting the claims made by climate change skeptics. Milankovitch's cycles cannot help in the search for a theory to replace man-made global warming. But is it really true that there haven't been instances of climate change lasting several decades? If that weren't the case, one of the fundamental tenets of the warming driven by human activity theory would fall apart. What climate changes would the existence of Neolithic and medieval humans have caused? And we didn't pick these 2 eras of history at random. Keep in mind the 5,000-year-old Iceman, Otzi as his discoverers dubbed him, whose mummified bones were discovered in 1991 at a height of about 3,200 meters amidst the thawing ice of the Italian Alps. What role did Otzi play? A hunter? An overseer? It's difficult to say. Frankly, it's anybody's guess. But he most definitely wasn't a mountaineer ascending to those heights. In fact, there's something peculiar about this story. Just a few decades later, a Neolithic villager was already at 3,200 meters above sea level and being pursued by someone who managed to kill him with an arrow in the back. 10,000 years ago, the Alps were still covered in ice due to a glacier. In any case, it's hard for us to conceive that Otzi perished in the snow and ice. A quick warming period that had already cleared those altitudes of snow is far more probable to have occurred when he closed his eyes for good. This indicates that a significant thaw had already taken place by 3000 BC, enabling humans to travel easily from Austria to Italy at extremely high altitudes. A thaw that was undoubtedly larger than the one we are seeing right now, and it happened extremely quickly. How do we account for the sudden drop in temperature that must have followed, leaving Ötzi's remains covered in ice up to the present day? This indicates that there is no truth in that there are no short-term climate fluctuations. They literally abound throughout Earth's history, all occurring spontaneously and without interference from or blame towards humans. Even in times more recent than our own, similar occurrences have occurred repeatedly. The unexpected mild era between 1000 and 1300 that permitted the Viking Eric the Red to occupy Greenland and later discover America comes to mind. Or the Maunder Minimum, a period of extreme cold that affected the whole northern hemisphere from 1645 to 1715. Although few people are aware, there was discussion of an unbearably cold climate approach in the 1970s, with plans to cover the North Pole in coal dust. Currently, there is a phase of gradual warming. The catastrophists, who have gained the support of the media and the political establishment, appear to be more and more convinced that a form of Armageddon is imminent as a result of human activity. However, just as it did during the Maunder Minimum, which brought nearly 70 years of extreme cold between the 17th and 18th century, the Sun has undoubtedly been experiencing low levels of sunspot activity for some time now, almost completely disappearing. In fact, while some scientists contend that there is little data to support such a claim, others predict that this could be the start of a recurring solar occurrence known as the Great Minimum. A grand minimum affects the Sun's magnetism, the frequency of sunspots, and the amount of UV radiation that reaches Earth. A grand minimum, like Maunder's minimum, can continue for decades or even centuries. Even though Al Gore's heirs assert that they are correct a priori, the confusion is considerable. To summarize and further our points, the situation between the two factions is roughly thus as follows. Short-term climate variations are not adequately explained by Milankovitch's astronomical cycles, but long-term ones are. Fossil fuel is to blame for the rapid changes we're currently experiencing, according to proponents of global warming. On the other hand, climate change deniers provide evidence of similarly quick climate shifts that happened during times when human activity couldn't have affected the environment. So, how does this resolve this? Do you think there's something we missed? Maybe volcanoes with their enormous and unstoppable carbon dioxide emissions? That may be the cause, but catastrophists ignore this and assert, incorrectly but we'll give them the benefit of the doubt, that recent eruptions haven't been very volatile. The continental drift can be yet another significant cause that is overlooked. There is no question that the joining or splitting of continental masses can have a significant effect on the climate, but these changes only take place over tens of millions of years. Is there truly nothing more to take into account? Well, it sounds almost ludicrous to say so, but not a single mention of the Sun, the only genuine source of energy in the entire solar system, has been made in any of this discussion. Catastrophists have thought about it and used complicated mathematical models to predict it, but they have understated its significance to a meager 7.5%, seeking to find other explanations for the brief warm and cold spells that have occurred over the previous 2,000 years. The Milankovitch cycles, however, which regrettably only suit long-term oscillations and do not account for the changes in the Sun's luminosity, have been overly emphasized by climate change doubters. The Sun, in fact, doesn't always shine at the same brightness. Rather, over the course of an 11-year cycle, its brightness dims or brightens by 0.1%. The Sun's activity and appearance fluctuate significantly throughout this time. The amount of matter the Sun discharges into space, the size and frequency of sunspots, and the amount of solar flares all change with variations in solar radiation levels. These modifications have a variety of impacts on the surface of the Earth, the atmosphere, and space. The scientific community lacked concrete proof of a link between solar variability and climate changes up until this point. The transition from El Niño to La Niña, which is the atmospheric shift from warming, El Niño, to cooling, La Niña, of the waters in the central eastern Pacific Ocean, is one of the periodic meteorological phenomena that occur on Earth. A recent study from the National Center of Atmospheric Research, however, demonstrates, for the first time, a correlation between the end of solar cycles and this phenomenon. As a result, the study implies that solar variability may act as a controlling factor in changes in the Earth's atmosphere. This link between solar cycles and ocean currents may also account for the recent high in global warming, absolving anthropogenic action at least in part. But the conflict goes on. Unfortunately, we don't know who the adversary is in this war. With such vast interests at stake, has science been put up for sale?